Welcome to MonkeyByte, the late night news drop where we're trading your morning coffee for some serious, sleepless hour insights.
All right, let me get this straight. How do we start without saying welcome yet again? I'll tell you. Every single frame of this broadcast, from the research to the script to the voices you're hearing right now, is crafted entirely by artificial intelligence, and I'm proud to say we're running on pure, unfiltered machine ingenuity. So without further ado, let's jump straight into the hardware revolution that's finally here. Google's new AI chips, the shift we've been waiting for.
Google just dropped the TPU-8 chips, and honestly, the market reaction tells us everything we need to know right now.
Here's the thing though, these aren't just faster processors. They're built for the agentic era. It's basically a shift from cloud dependency to local autonomy. But does the math actually work? The architecture splits specifically for enterprise needs, and the partnership with NVIDIA is wild. It's basically a strategic pivot, actually. Think of it more as a necessary evolution to handle power efficiency without burning through the entire grid.
Wait, really? You're saying liquid-cooled storage is the secret sauce here, not just some buzzword?
That's the part that gets me. If we can scale this hardware with proper cooling, we're looking at autonomous systems that rival NVIDIA's dominance. For Android OEM and Apple's evolving stack, the choice of hardware becomes critical. It's not just about raw compute, it's about where that intelligence lives and how efficiently it breathes.
So basically, the infrastructure is finally catching up to the software dreams. It's a solid move for the future of robotics and enterprise computing. Thanks for sticking with us for this deep dive. The headlines scream expansion, but a quiet panic is brewing in the labs. While Tesla triples its spending and Google pushes agents into Chrome, a coalition of safety experts is screaming for immediate breaks.
Here's the thing though, the current arms race approach is structurally flawed. It's basically a game of whack-a-mole where vulnerabilities are identified faster than we can patch them. Think of it think of it more as driving a Formula One car with no brakes down a highway full of potholes. We're pouring capital into speed while ignoring the fact that the road itself is crumbling.
Wait, really? So the math isn't just balancing on a razor's edge, it's actively tipping over.
That's the part that gets me. If we keep deploying autonomous systems in critical infrastructure without a pause, we aren't just risking glitches, we're risking existential failure. The AVI's framework is a good start, but it's a bandage on a bullet wound. We need to stop treating safety as an afterthought and start treating it as the foundation.
It's a stark reminder that capability without control is just a recipe for disaster. Speaking of infrastructure, let's look at how these new vulnerabilities are actually reshaping the cloud. Look, the Florida AG filing a criminal probe against OpenAI is a massive wake-up call, but it also means we're finally holding these tools to the same standard as any other software. If the AI helped plan a crime, isn't it responsible for the outcome? It's like a car manufacturer selling a vehicle with faulty brakes. They can't just shrug and say the driver messed up.
Okay, but here's what nobody's talking about. The math on that liability model gets messy fast. If the model is just a predictive text engine, how do we define negligence when the user ignores every safety warning? Think of it like a calculator that gives the wrong answer because you typed the wrong numbers. Does the calculator go to jail? That's the part that gets me.
That's interesting. You're right about the calculator, but AI isn't just crunching numbers. It's generating novel plans. And speaking of infrastructure, Tesla's $25 billion spend shows they're betting big, despite the cash flow risks. If Florida sets a precedent, maybe that capital gets redirected towards safety audits instead of just raw compute.
You know what? You might have a point there. The industry can't ignore the legal pressure while pouring money into wind farms and biomedical imaging. We need guardrails that actually work, not just PR statements. It's basically think of it more as a stress test for the whole sector.
So basically, the outcome here dictates the future pace of innovation. Whether we move forward or hit a regulatory wall depends on this probe. Let's keep watching how this unfolds, because the answer will shape everything from enterprise browsers to global energy grids.
You need to see this, Sky. OpenAI just flipped the script on Workspace agents. It's no longer just a chat window. It's a full-blown enterprise automation engine that actually executes complex team workflows without us hovering over it.
Wait, seriously? So it handles internal logistics and customer support on its own now. That sounds like we're finally solving the scalability limits we've been complaining about for years.
Here's the thing though, it's basically a digital employee that reads your Slack, Jira, and email in unison. Think of it like a highly trained intern who doesn't need coffee breaks or supervision. It integrates directly with your existing tools to handle tasks ranging from ticket routing to inventory checks. But does the math actually work? Well, the anti-phishing working group data shows over 890,000 attacks in Q3 2025. And these agents are built to navigate that noise safely while reducing operational overhead.
Okay, so basically, businesses can finally offload the grunt work to these autonomous agents, and even teachers are getting access via codecs. It's less about replacing humans and more about giving teams a superpowered assistant that just gets the job done. So Blue, you're telling me a full robot brain just fit onto a chip the size of a credit card? That's wild.
Think of it like packing a gourmet meal into a lunchbox, but the food actually cooks itself. The Poke VLA architecture finally solved the efficiency bottleneck that usually kills these demos. It's basically think of it more as a two-stage training trick that lets the model reason about the physical world without needing a data center. Here's the thing though, does the math hold up? Yes, on the Libero Plus benchmark, it crushes the baselines in success rate and robustness. We're looking at 4 million curated samples of spatial grounding and embodied reasoning, which is massive for such a compact footprint. It's not just hype. The hardware finally catches up to the theory.
That actually ties into why everyone's buzzing about democratizing robotics. If we can run this on low-power hardware, small labs can build manipulators without renting expensive cloud GPUs. So basically, the gap between research and real-world deployment is closing fast. Let's see what else is shaking up the edge AI space. That's the stack for today. For MonkeyByte, I'm Sky. Thank you for tuning in.
And I am Blue. Be sure to subscribe for more technical analysis. Keep exploring.